The question of energy is certainly the biggest problem we have to solve today. The proportion of world energy demand directly ascribed to buildings is about 50%. If this also included the indirect energy demand of buildings, the total value would be significantly higher. The solution to this problem can only be found in developing new energy sources, or preferably in optimizing the technical systems of buildings. Both approaches are important, but reducing energy demand is far more significant. This will also not be achieved by lowering the standard of living in developed countries or by the developing world remaining at its current level. The focus of our research lies in exploring new fields in the holistic planning of buildings and cities, aiming to maximize energy efficiency and the level of comfort. Computer simulations are the methodological emphasis of our research. In our Institute's research department, we are currently focusing on design strategies, methodological strategies, and the development of software design tools to evaluate the effective increase in the energy efficiency of buildings and cities, in order to develop three central working models: spatial densification of cities, decentralized energy and food production, and space-time densification in usage open structures. The Institute for Buildings and Energy always thinks in terms of systems. In architectural development, the building is seen as a product of aesthetics, energy consumption, and the quality of the interior environment. It is also an integrative component of the urban environment, as well as a unit of a spatial distribution of functions embedded in an infrastructure and traffic network. There is scientific evidence that reduced transport and infrastructure energy demand can be linked to increased urban density. With a higher urban density, building energy demand decreases. Taller and deeper structures create increased requirements for grey and operating energy, with a negative impact on the gross net area ratio of buildings. The impact of spatial concentration on decentralized building integrated energy generation through renewable energies is an essential part of our research and an integral parameter of the overall picture. It is undisputed that spatial concentration fundamentally contributes to increased energy efficiency. However, it is necessary to determine the optimum degree of urban density by considering all essential impact factors such as buildings, transportation, and infrastructure. Our institute is evaluating potential energy demand reduction with the research program Consequences of Teleworking and Energy Efficiency, analysis of the interaction between teleworking and the total energy efficiency of buildings. The project is part of the Energy of the Future program of the FFG, the Austrian Research Promotion Agency, and supported by the Climate and Energy Fund. The project is analysing the connection between various kinds of teleworking and the total energy efficiency of society. New types of work models have led to a clear increase in energy demand in recent years. The consequent structural change in the physical and virtual infrastructure of society, buildings, traffic, and IT systems, provides potential to increase total energy efficiency. In our studies of teleworking, we don't represent the energy structure of buildings or cities, but of service companies. External experts from the fields of sociology, traffic, and IT are also involved. On an architectonic level, the city configurator software will be the result. This design tool will help to find potential to reduce the net floor area of companies without increasing the area needed by teleworkers at home.